Good afternoon. I decided after our last video that I wanted to do one more of these, and I picked a small problem. We don't have to calculate the reactions that the supports in hopes that I can clarify the discussion and the questions I've received with regards to the tension and compression piece. All right, so uh, we start the problem the same way, and then as we get to it, I'll end it in a little bit different way. That's my plan anyway. So there's no reactions to support the reactions. Our directions are to calculate the internal forces of member AB, BC, and AC, and then determine whether they are in compression or they're in tension. We have to start someplace. We have to start at a joint where there are two or fewer unknowns. In this problem, that would be true in all three joints that we could choose. I'm going to start at point A. So point A, we've got a 2400 Newton force being applied upwards. We have member AC, and we have member AB. Go ahead and label those real quick. Member AB, AC, and 2400 newtons at point A. All right. So AB is at a angle. The angle that we're given is 47.6 degrees. That's the angle between the horizontal and AB. So I'm going to just draw a real quick picture. So here, be AB. So AB, that's AB. This will be AY. This would be AX or ABX. So ABX is going to be AB times cosine 47.6 degrees. ABY is AB times sine 47.6 degrees. The 47.6 degrees comes from here, and that comes from the initial picture. And I'm going to start with summation of the forces in the y direction. So summation of the force in the y direction, 2400 newtons minus AB sine 47.6 is equal to 0. Subtract 2400 for both sides. We'll get negative AB sine 47.6 is equal to negative 2400 newtons. Divide by both sides by negative sine 47.6, and we'll get that AB is equal to 3250.03 newtons. So that is a positive number. It means that my guess is correct with regards to which direction the arrow is showing. The arrow is going into the joint. That is the indication. If the arrow is going into the joint, that indicates compression. We're going to come back very quickly after we get the last two calculations and talk about why, which I guess I should have done 2 days ago. We can now look at, so that gives us what we got, AB. We're at A, so we'll go ahead and grab AC. We can do that by looking at the summation of the forces in the x direction. Negative AB cosine 47.6 plus AC equal to 0. We know AB, so negative 3250.03 newtons times cosine 47.6 plus AC is equal to 0. we get that AC is equal to 2191.50 newtons. Positive number means that I have guessed correctly the direction of the reaction of member AC. It is, since the arrow is pulling away from the point or the joint, that's indication that that is in tension. I'm going to pause the video while I erase the board to get set up for our last calculation. Hello and welcome back. We need to take a look. So we have AB now, and we have the internal force of member AC. That leaves us with the internal member or force of member BC. Drawing a free body diagram for BC. We have a 1200 Newton force pushing into BC. AC we said was in tension, so we'll draw that picture in tension as well. And then I'm going to go ahead and assume that the arrow for BC goes that way. And we'll talk about why in a second. 1200 newtons. AC was 2191.5 newtons. I'm calling this BC. Why did I guess that it was pushing into point C? There's only one horizontal force, and it is going from left to right. That indicates to me that, if it's in equilibrium, then I've got to have one that goes from left to right. The 1200 Newton is the only vertical force. It's going up, which means that I need one that counteracts that, so it's got to be going down. So if I've got a horizontal force going from left to right and a vertical force going from top to bottom, the overall is what I have, a downward C. I guess that could have been a solid line, right? All right, so BC, this angle is 28.7, that's given. Vertical component is BC, or horizontal component, I'm sorry, is BC cosine 28.7. Vertical component is BC sine 28.7. I'll just, doesn't really matter at this point whether we take the X or the Y. I did the calculations for the Y, so that's what I'm going to pick. Summation of the forces in the Y direction equal to negative 1200 or positive 1200, I'm sorry, newtons minus BC sine 28.7 degrees is equal to 0. Add BC sine 28.7 to both sides, we get 1200 newtons is equal to BC sine 28.7. Divide both sides by sine 28.7, and you end up with that BC is equal to 2498.84 newtons. I have a positive sign, which means that my arrow guess was correct. The arrow is pushing into the point, which is an indication that BC is in compression. All right, I'm going to pause one more time to erase the board. I want us to talk about one more thing. The whole reason I'm doing this problem actually is so I can show you this next piece. See you in a second. All right, took me about a minute longer than I thought it would, but I've got the board erased. I've got our answers on the right-hand side still, saying that we thought that, kind of what we calculated out. I've moved one of our free body diagrams to the right. On the left underneath our original picture, what I have done is exploded the picture. So I'm labeling, remember, AB, BC, and AC. I've shown the forces without the values, the external forces being applied without the values, just to facilitate an easier discussion. And I just want to draw a couple things up here for us to see. Our free body diagram for point A looked like this. Our free body diagram for BC looked like this. Okay, we said that AB was in compression. AB was in compression, right? So if AB is in compression, it's being squished in. The forces are pushing them in, like I've got the arrows indicated. Right? That means the reaction to that would be opposite. Right? So we said earlier that if the arrow is pointing, if the force is pointing into the joint, that is indication that the member is in compression. Hopefully pictorial, you'll see now why. Right? So if the reaction at joint A is pushing into that joint, the opposite of that is pushing away from the joint. In other words, the member would be in compression. We found that AC was in tension. If AC is in tension, then the internal force in AC is stretching the member, if you will. Okay. And we said that if we had an arrow pulling away from the joint, that indicated that the member was in tension. Notice that if the member is in tension, the reaction to that would be an arrow in the opposite direction. Same thing with BC. We said BC was in compression. In other words, the internal forces keep that member in compression, trying to squeeze it together. So the opposite of that, the opposite of going in is pulling away. That's why the reaction at point C for BC is an arrow that goes into the joint. So my hopes is that kind of clears up a little bit and helps to finalize and build up our instinct. The next video I make is going to be for the next section. I'll see you guys in a little while. Bye-bye.